Hi.
Hope you're having a good December.
Thanks for joining us today. Okay, we're testing out a new configuration, as you can see.
We have a new webcam and we have a new microphone. So
So-
hopefully you will be able to hear and see us a lot better.
Yep, if not, you can just feel free to feedback to us as well. Okay, hi.
Actually, wait, before we start, just a quick note to everyone.
Yes.
All these sessions are recorded and uploaded to YouTube. So, if you need to go somewhere, if you miss something, don't worry. You can always, sort of go YouTube and resume everything, right? Whenever you're convenient or free.
Yep, that's right.
Yeah, so shall we get started?
Yes.
Okay.
All right.
So thanks for joining us again. Melody, this is John and this is Tuya, and
Hello.
today we will be giving you an overview on SQL, what you've been doing the past week, and we'll also answer some of the questions that you had for us. And then after that, John will give you a quick introduction to Google BigQuery and how to use what you've learned this week to make searches on the cloud. So shall we get started?
Okay, let's go with question one.
Right.
Yeah,
So wait,
before we start,
can they
yeah.
see the questions? I see this thing on the screen,
Yes.
but okay, so you can see the questions.
All
Great.
right. But before we start, I have a really important question. What is SQL?
Right. So most people will either have a lot of experience with SQL or zero experience with SQL, depending on what you're working on, right?
Okay.
Over the past few years.
Yeah.
So for those who are completely fresh and new to this, don't worry, we will start at the beginning. For those who know exactly what SQL is, just bear with us for a little while. SQL stands for Structured Query Language, right? It is a completely separate programming language from Python or C or JavaScript, right? So you can think of SQL as a different language that you use to deal with data.
Yeah, so SQL is mainly used for processing your data, reading it from it. When you try to store it, you can either store in CSV file or some people like to store in SQL database, which has a lot of queries, a lot of rules, and a lot of records in it.
Okay.
Yeah, so you sort of like use it to read from or write from. So it's like some consistent entities there for you to store your data, and it's there whenever you need it. Yeah.
Okay, but John, you mentioned that it's a completely different language on its own, right? So how is it different from the other languages?
Right. So I think what people need to sort of understand in order to appreciate SQL as a language is that SQL is what we call a declarative language, right? As opposed to an imperative language. So, kind of analogy is when you have a declarative language, you're basically telling the program, I want you to do something, you go figure it out how to get it done best, right? But in an imperative language, Python is sort of imperative, so you can think about Python. You have to tell Python exactly how you want something done. You can't just tell Python, go do it, right? It would not be able to do that for you. So that's the big benefit of SQL, right? Basically, you have data stored somewhere, it's a lot of data. You just tell the program, I want this data from that place, go get it. I don't care how you do it, right?
Okay.
And then, it retrieves that for you.
It is quite different in the sense that you can't use SQL to build like website or some apps that very cool app, for example, mobile app. So it's very different from Python, which you can use to do some other things like building a web app or mobile app.
I see. Okay, so in the bigger data frame, data science context, how is it important?
Right. So, you might be thinking, okay, so far on data camp or in my own experiments, I've just brought the whole CSV file. I've just brought the whole TXT file into my computer, right? Like, why can't I just, like skip this whole SQL thing and then just make the data on myself? You can, right? So actually, that's one important point. When the data is small, you can sort of hand, shape it and deal with it manually. But when you have big data, when your data goes into terabytes, right, or petabytes, you can't have that on any one computer, right? That has to be stored in the cloud. And when you want to pull out slices from there, how do you do that, right? So that's where SQL really comes in handy, right? It lets you query, this huge data storehouse in the cloud, and it just returns you exactly what you want. It really cuts down on your compute time, your storage costs, right? And basically makes your life a lot faster and easier when you know alias.
Yeah, in a way, there's another way to use SQL is basically for concurrency issues. So for example, if you're going to use your CSV file as a source of truth, so you have programs on top of it, try to read it from it, try to update at the same time, you sort of have like some inconsistency between these entities that try to read and write from it at the same time. So SQL in a way sort of handle this kind of multi-threaded or multi-process instructions. So it's sort of like store a sequence. So if you're going to update it before someone else read it, they try to update the rows first so that they will always get the latest data.
That's actually a very good point that Tuya brought up. I remember once I had a professor who was telling us exactly why this was really important, and he gave the story about a bank account, right? So imagine if a bank stored your bank account on like a CSV file, and they did not have a way to log the transactions in the times that they came, right? You could have like people going in and out and withdrawing money, but because of the different times a program on the internet would take to lodge those things, then you could actually overdraw your account, right? Have a negative balance without the bank even realizing it. So SQL solves those problems, right? And that's why it's important as well.
I see. Anything else to add about what SQL is, what it does, how it's important?
So how it's important is basically in SQL they maintain ACID property, like ACID property in the sense that accessibility, credentiality, and durability. So if you have a CSV file, then you have, if you encounter this kind of condition where you have multiple CSV with like final version 2, final version 3, there's a lot of inconsistency between which you don't know which one is the latest. So let's say your boss asks you, I want the latest report. Then you have final version 2, but your colleagues have final version 3, which sort of like inconsistent some data that you present it. It's all different data set, right? So SQL in a way sort of consolidate all this version. So you can have like snapshots, and you can even like create views on top of SQL to see only the things that you want to see. For example, you have 20 columns in it. You create a view of only 10 columns. Then that view sort of like exists in virtual world. Then you can sort of only reference to that 10 columns that important view first before you get export to 20. We sort of save time in a way.
And I think one thing to note, right, for those of you who might want to explore more into SQL, there are many providers of SQL in the market, and unfortunately, this is one of the strange times where everyone has a slightly different implementation, and no implementation actually fully adheres to the SQL standard, right? So if you pick something up, just keep in mind that any tutorial that you find online or any way that someone is talking about SQL may not actually apply to the current version of SQL that you're using. Right? You need to keep that in mind. And that's also why I would say don't sweat too much about SQL. And from a data science perspective, you're not going to be using SQL all day long. You just need to know how to grab the data, right? Then you can sort of
like process with data cleanings and feature engineering.
Correct. So you wouldn't actually need to like go super deep into SQL, right?
Okay, thanks for sharing, guys. Now let's move on to the next question. Okay, how do table alias names affect performance?
So this was one of the technical SQL questions that we received this week. And it was actually, I thought, a very interesting question, right? Because the alias in SQL actually is sort of presented as an optional thing, right? And basically the answer to that is that if you don't give your tables an alias or a name, if you change your tables next time, if you add columns, right? If you separate it, if you join them, and your query is still the same, like it might not know exactly what you're referring to anymore in this SQL program. So you can end up what we call breaking your query, right? Or you could set it into an infinite loop, right? So it's an error or the processing time goes haywire. Because again, SQL is a declarative language, right? So you're not telling it how to do it, you're just telling it what I want, right? So if you didn't really give it good directions to what exactly you want, it sort of gets lost.
One sort of things of using alias is basically, let's say you have multiple tables and you want to join them together. Then there are some column names which are say, for example, you want to join a person table with student table. The student have name, the person also has name, right? So how are you going to identify these two? If you're going to if you don't use alias, you're going to type down person.name equal to student.name. You get confused over time if you have multiple student names, student 1, student 2. Yeah, so these kind of things sort of help in terms of memorizing or remembering the query and the syntax of it.
Okay. Any good practices for giving people aliases? Yeah.
Usually people just give, like for example, students, they will just say S1, S2. So they start with, some people like to start S0, S0, S1, or maybe S1, S2. It's really up to how you understand it. It should be very like descriptive enough for someone who has not worked on your project to understand. Like for example, a person, you can just say a person table is like P.
Or if you use funny names, make sure you document it somewhere.
Yeah.
It might not be someone, it might be yourself back a month later. If you don't understand what you did, then you have to spend time to refresh yourself again, right?
All right. Anything else to add to this question?
Not much.
Okay, cool. Let's look at the next question that we had. What are some resources to practice SQL?
Okay. So I think that when it comes to SQL, you should read less and practice more. Right? Really, the understanding of how to use this language comes from having time, querying different kinds of data sets, joining, separating, like grouping things together. And what I like, right, to sort of think to myself, right, especially when I was like first starting SQL, is the three main words. It is very Singaporean, right?
Okay.
Just ask SQL, select from where.
If
look at the slide, right? Select something from somewhere where something is going on. So it's not really like select from where, but it's like select from where, right? But it was a good mnemonic for me, right? So once you have these three main words, right, you've basically been able to pull something out, right, from your database. And then the other things like group by, having, order by, limit, and offset. These are all just sort of sub-expressions that allow you to more finely tune or sort of reshape your data, right, from the database to give you what you want more easily. You agree?
I'm sort of agree in the sense that you have select from where is really different from the English language select from where. So select in a way you are selecting, like you're pointing a location where you want to do, and from is basically let's say you have a list of tables. From this table I want that, right? So it's from. Then where is basically a condition. For example, you have a set of books. I want the books with cover red colors. I want the books with written in English or something like that. And there's more like average, which you can use with group by, or you can like aggregate functions like sum, count if, all those sort of things. These are really like fine tuning, as you said. And it's really good if if you are very proficient in SQL. You don't even have to select everything from the start. Save into your memory. Try to process it. What you're going to do, for example, you're going to like find means of particular columns. You can really straight use it in SQL instead of putting it into your notebook. You try to put it into data frame and you try to bunch them. Yeah, so it's sort of like save time in a way. If you know what you want to process, you can process them at SQL level, which is so much faster to process on the
because otherwise you have to pull everything from the internet, right, into your your intranet, which could be even slower, right? So that's something definitely to keep in mind. Then after that, what you see at the next point here, subquery and common table expressions. Really, it's shaping your data.
And there's a lot of ways that you can improve your SQL queries. So there are things like SQL optimization. You really calculate the decision tree of the SQL. And you try to find out, what's the optimized version of it. You try to write it in the ways that it reads in like 1 second or 1 millisecond, something like that. So there are a lot of things that you can do in SQL, but as a data scientist, you probably wouldn't be doing so much in this sense. It's more toward like database administrators to do this kind of queries, fine-tuning your SQL statements or sort of things. It's good to explore, but you don't really need that much like domain knowledge to really get into that level.
Right. Okay, and I think one of the things, especially if you're coming in fresh to SQL, is visualizing is very important, right? Like, if you just see a bunch of words on the screen, it might be difficult to understand why you are getting something or not getting something. So you can go to this place called SQL Zoo, or you can go to this place called SQL Fiddle, and they on their website you can practice, and there are strong visualization interfaces there as well, right? So if you want to practice SQL, definitely check out these two resources. I think they're quite good at getting you sort of up the curve, right, to where you need to be.
And also mindful that different SQL version, they also have different syntax. For example, MySQL and PostgreSQL, there's slight difference between the syntax. So if you encounter some SQL databases that doesn't work as you intended, for example, you're writing in MySQL syntax, it doesn't work on that particular SQL statement. Don't worry, there's slight difference there, so you have to just mindful of that. It's not going to be like, just port over, run it, copy and paste it, then it's going to work. You have to do some changes to be able to work in multiple SQL versions. Yeah.
Right. Okay.
Okay.
Okay. So we're all going to get stuck, right, at some point. So we got this question, and so we're going to try to give you like 4 or 5 tips to think about what you could do, right, if you're stuck. So tip number 1 is try to write a query on a smaller piece of data. Like why would we want to do that?
So I think it's because if you want to select a certain set of data, which is small enough for you to read it, it will perform faster so that you can do multiple iteration like really fast. If you're going to select like 100 million rows, then it's going to take a long time to even select everything before you even get to see my results, right? And if you have a lot of data set, it's very hard for you to visualize it unless you put in something else. And even then, you sort of like can't even say much what went wrong in your selection, right? So it's good to have like sample of data. You try to process with that sample data. Then once you get everything right, your logics are right, then you move on to the big one. That's what I think.
Yeah, I think that's absolutely right. Whenever you're encountering a problem, there's always is the data sort of unclean? That's why it's throwing an error. Is my code wrong? Is that why it's throwing an error, right? And when you're exploring this, you don't want to be limited by your processing time, right? And your back and forth becomes really long. So yes, that's number 1. All right, number 2. Ask yourself, how can I solve this problem in a single query, right? And to me, I think the reason we want to do this is that if you have multiple queries going on, it might distract you from thinking of like what is the cleanest way to get there. But I think this might be an opinion. Like, what do you think? Would you rather try to split the thing into many different pieces?
So my takes would be you can start small first. So if you're not sure what you want to do, you try to get it right by setting small samples, like small queries. For example, I want to select everything first. After that I receive this type of data. I'm going to aggregate them. I'm going to get the sum of it. You can try like 3 steps to get the sum of it. Then you realize, oh, actually what I really need is not a sum, it's the average. Then you can sort of change it to average. Then you get what you wanted. Then you can match all these queries together, as the next step, so that you have something to compare to. If you have like a one query that does everything. Yeah, so that's how I really do it.
Right. So it's kind of how you think, right?
Yeah.
Basically, think. Don't get stuck. Just try and take it apart, put it again, right? See what's going on.
What about readability though? Which one would you think would be more readable to maybe yourself or to other people looking at your?
The thing is, there's always a trade-off between readability and the optimization. So if you write a very long SQL query, it might not even readable for some people who don't have much knowledge on SQL writing. So the ideal way is you sort of explain what you're trying to do step by step as a documentation or solve. Maybe you can even have markdown columns in your notebooks explaining what I'm trying to do with this query before you even write down a very complex query, right? So that people sort of understands from your writings and say, oh, actually this query is trying to do that, even though I can't really read it myself.
Right. Otherwise, if they wanted to modify the query or make some changes, they would not even know where to start, right?
Yeah.
The change will break the query.
Also, from my approach, I start with small queries. So what I do, I just merge them together and comment it out. So if they want to try from a fresh perspective, they can refer to my small queries and see, oh, this is how it's being transformed into the big ones, right? So if they want to change modification, they can refer back to the small queries and see, oh, maybe this is the line I need to change, then they change it, they merge it back again.
That's strong documentation.
Yeah. So the thing is, in software engineering, you don't really like to write documents per se. A lot of people don't really like to write a lot of things on their text or their code. So having that strong documentation really help other people, and maybe for yourself, maybe 1 year down the road, you really forget what you written. Yeah, so it's really good to have note down everything. Now it's very easy because in notebook, right? So notebook you have a code segment, and you can also have markdown segment. So if you're writing code at the back, you can just slowly write your markdown as well, so people can straight away see your codes and the documentation at the same time.
Yeah, it's a good habit. It's a good habit to get into. Right? All right. So and another thing you can do, right, is think, can I, instead of pulling out, the whole chunk of data, right? But what can I filter? What can I aggregate? What can I join, right? And then here, if you're really stuck, instead of trying to solve the problem with SQL first, maybe I can take a subset of the data and figure out how I want to manipulate it in Excel or graphical interface, right?
Okay.
And once I sort of see, okay, I did this, then I did that, and then I did that thing after that, then you can sort of translate your actions in the graphical interface to what the SQL code should be, right?
So it's good in a way that you sort of use Excel to try to find what's the sum of it, what's the means of it, how do I get this set of data from like limit to like maximum or minimum based on that. So the things to take note when you try to use Excel is that you are trying manually, right? So sometimes you forgot to take down some steps, and you might even like without even realizing that you are doing this step because it's too natural to you. Then you sort of like forgot to transform it back to SQL query, and because of that, your SQL query gives you different results. Then you're like, hey, what did I do wrong? Yeah, so yeah, it's good to write down the steps that you take. So every time you say I want to filter this particular column to like top 10 or top 20, you sort of write down every single step that you do. So that when you try to transform the SQL query, you don't miss any steps. Yeah.
Okay. And yes, so this is how you spell SQL Zoo and SQL Fiddle, right? In case you didn't hear fully the last time around.
Okay. Database normalization versus data pre-processing normalization.
Aha. Okay. So this question came in on a poll EV. I have sort of shrunk this question into sort of a concept, right? The question on poll EV was asking, like what is normalization when it comes to databases. So I thought this would be a good time to sort of take a step back and sort of explain how this word normalization is actually used in multiple contexts and can be a little bit confusing, right? So the thing to understand is that when we talk about normalizing a database, it's a completely different concept from normalizing the data that is inside of the database, right? So we'll talk about normalization of the database first, because this is SQL week, right? And I think one of the things that people should sort of just keep in their mind and understand is this concept of normal forms, right? So if you're prepared, we will dive into normal forms, right? Okay, 1NF, right? First normal form. This is basically what everyone sees as a table. I think most people actually put data in 1NF, as it's just good practice.
They just write it down somewhere.
Yeah, it's what everyone does, right? Like no one would create a table where they put multiple values in the same cell. That's kind of weird, right? So you probably already are doing 1NF, so yay, congratulations, right? The only other thing to kind of note is that in 1NF they have this concept of no repeat columns. So if you want to know more, just go on Google and there'll be a bajillion examples on what the 5 different ways no repeat columns actually sort of take, right, in the real world. Anything you want to add?
The repeat columns can be sometimes it's represented as different format. Like for example, if you're going to get gender of a person, then there can be male and female, right? So some columns there's male and female, some columns is like 1 and 2 or 1 and 0. So these are sort of like different value, but they are actually replicated columns. So it's not just like repeated in a ways it's different, same format, same column. It can be different value, different column, but they mean the same thing. So this kind of column you have to like remove it out.
Keep in mind, right? Okay, so 2NF. What is second normal form, right? Second normal form is first normal form plus this thing called a primary key. I wasn't planning to touch on primary keys today because I think that gets very complicated very fast. But do you have a 1-sentence explanation?
Take it as primary keys are sort of like identifier for records. So for example, you have a ledger, like a voucher or something. You have like serial numbers like 1, 2, 3, 4, 5. Those are actually primary keys. So it's sort of identifying the single rows of the data in the database.
So unique identifier.
It's a unique identifier for that particular table.
Right, but it does also get complicated quite fast. So again, if you want to find out more about primary keys, you should definitely hit up one of the SQL learning sites and check out more like what these things actually sort of translate to in real life. All right, now third normal form, right? Second normal form plus this concept called no transitive dependency. Should we talk about that?
I think it's mainly meaning things like when you can sort of derive something from using existing columns like total. Total can be the sum across all the columns, right? So you can get that sort of column by using SQL query, so you don't really need to save that column in that database, so that you don't have to waste a lot of space. You don't create inconsistency because every time you update the particular columns in that row, you have to update the total as well. If you forgot to update your database and inconsistency issue.
All right.
Yeah, it's something like that. That's what I get.
I think that's a good explanation.
Yeah.
Right? Like the total concept, right?
Yeah,
you don't need to have that in
have
your,
that.
you can calculate that by yourself, right? But it doesn't stop there,
Okay.
right?
There's
There
more.
is 3.5 NF and 4 NF as well, right? And here, other things like super keys and multi-value dependencies start to come in. I think we won't confuse you with, what those things are. And we'll explain why in a moment, right? But let's now shift and talk about data pre-processing and normalization, right? This is a lot simpler. This is why I'm a data scientist, not a SQL guy. So the concept behind normalization is that you basically want to transform the values that you have in your data to have a mean of 0. So if you think about your x and your y axis, it's exactly where the center is, and a standard deviation of 1, right? And the reason you do this is so that if you have multiple features or columns in your data set that have wildly differing absolute values, you actually sort of get them to line up. Here, normalization and standardization are used interchangeably, right?
Okay.
So a big point of confusion is always, is standardization different from normalization when it comes to transforming values? Like, generally the answer is no, right? But there are other ways to standardize your data, right? But generally, when people say normalize or standardize, like the first stop is mean of 0 and standard deviation of 1, right? And then if you want to do something else, then you sort of add on more detail, right, about what this standardization actually is, right, going forward. So for example, in neural nets, like one of the standardization measures you want to do is you always want to sort of change your values to be between 0 and 1, right? So that is another different kind of standardization, right? So there's something to definitely keep in mind.
So as you can see, the normalization in data science sort of different from normalization of databases, which is not for database why they are tempering the columns, the arrangement of it, having the primary key, super key, whereby the data science is more towards cleaning the data, transforming, shipping the mean value, getting standard deviation to 1, transforming into like log normalization or something like that. So it's really different from like domain, database domain, data science domain.
Right. Yeah. So basically, you normalize the database so that like you can manipulate it more easily. But you normalize the data so that you can perform statistics on it more easily.
Yeah, that was a good explanation.
All right. Now, this is my favorite question. Should I normalize, right? And why I think that it's not a big deal if you don't really normalize your data. Because if you look at this chart, right? This is actually a true diagram of a database that some company has somewhere, and it's managed by a database administrator, right? So, if you are a data analyst or someone that needs to build the data, actually what you have to do is you have to, print out this schema, you have to look at it, then you have to go talk to your database administrator and say, look, I'm trying to get this data, right? Just letting you know, right? Please let me know if there's anything that I should keep in mind, right? Because he might have some funny stuff going on in there as well. And then then you go, right? And you don't actually get to change any of these things, right? It is the full-time job of database administrator to actually make sure that this thing doesn't break, right? And whoever is trying to get the data doesn't actually override the data or like do something that causes the whole sort of system to break down.
So I sort of like agree with the data analyst cannot like change the data structure or data schema of the database. So in practice, what happened is they sort of like send requests to DBA, and DBA will just do things like creating custom table or custom view, or maybe even like a dummy table for the data scientist to work with. So let's say I want like 20% of the database, but I want it from 2 columns from this table, 2 columns from that table, like a whole column from this table. So they have like these store procedures or some SQL statement that they store it, like it runs on daily basis or monthly basis. So they sort of create one query for you. So every month you will get the data that you need from that temporary database, not on the actual database. Yeah. So DBA people sort of like does this thing for you.
Right.
Yeah. So you don't have to worry if you can't change much database. It's like, oh, you don't have to panic. You just have to talk to the right person to get the data that you need. Yeah.
Yeah, but also as a person that sort of is dealing with data, right? Whether or not you should normalize your table for someone else is also an important question to sort of look at, right? And here again, some key things to take note of, right? Like number one, if you normalize your data, right, it tends to get broken up into these different chunks of things, and then when you want to analyze it again, you have to join them back, right? And joins, especially if the data becomes really big, can become very expensive, right? So that's one reason why you might not want to, pursue, super normalization, right, of your database. And it's difficult, right? If you want to, where do you stop? If you go from 1 to 2.
Usually the practice here is there is this thing called BCNF, which is somewhere between 3NF and 4NF. People sort of start around 3 to go BCNF. You don't really go for 4 unless you really have a very strong DBA team that can do that, and you see sort of like some benefits from going to 4NF. So people sort of start around 3 by 5. Yeah, that's the industry practice.
Right. Yeah, and like the reason is because like also normally when you're doing data stuff, you're exploring a lot, right? Instead of trying to put something into production that will be used over and over again. So you have a lot of prototypes, right? And if you have to do a lot, then it takes time. So you might want to sort of just do what is the bare minimum for it to work, and then move on to the next thing, right? And also I think one thing to bring up is that SQL isn't the only thing that can be used. For querying. There are also no SQL databases out there, right?
Yeah. So no SQL in a ways, is sort of break down whatever you've learned from SQL. So they are totally different sort of things. We won't be discussing it here because it's all about SQL for this field, right? SQL.
Yeah, but it's just keep in mind, right? That this thing does exist as well, right? So there are multiple ways to cut data, and just as a matter of broadening everyone's horizons. Okay.
All
right. We had one question come through the poll EV as well, and that was around saving of a data frame. I thought it would be interesting to show people, right, how they can actually save a data frame, because I myself, I've worked half an hour on getting my Titanic data set to be exactly the way I want, and then
you shut down.
I shut down, and then oh no, like I have to run everything again, right? And it might take an extra 5 minutes or something like that. So we can save it, and shall we? Let's walk into this Jupyter notebook. Let's bring it up, and we'll show you exactly how, right? So the first thing you want to do is to import, right? So here we're just using 2 libraries. We'll import pandas, your favorite library over the last 5 weeks, and we also import a library called pickle, right? And pickle does exactly what it is. It pickles your data frame and it stores it somewhere for you, so that you can unpickle it later and put it back inside your notebook.
Is it gluten free? So let's carry on.
So let's execute, right? We've imported this. Now we need to set up a data frame, right? So let's just set up a data frame, with very simple values. We'll create a dictionary, right? Columns are A, B, and C. Values in the columns are 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So let's go. Now it's a dictionary. We put it into a data frame. So we execute pd.dataFrame. So now it's in a data frame. And then all you need to do to save this data frame to a file is to do pd.toPickle, right? And then you define the file name. So here / means like in the directory.
In the same directory.
Yeah, it's here. We just save it as a test file, right? So boom, that's all I did. So now it's in. Can we actually see that the file has been created?
It's here. Yep. You can see this test file too.
Right. So right there, right? So test file came up. We just saved that.
Yeah.
1:38 p.m.
Is it small?
Jupyter Notebook can zoom in.
Ah, there we go. Okay. So now you saved your file. It's in your folder, right? And you want to bring it back, right? So how do you bring it back? You just go pd.readPickle, and then you tell the function what the file name is, right? So let's go ahead and execute that. And okay, now you have data frame number 2, right? But what is data frame number 2, right? If we just sort of check it, we realize, hey, the pickled data did not give me back a data frame. It gave me back the dictionary, right? That I just defined. So that's something to keep in mind, right? It's something that could give you an error if you are not, sort of focused on it. So keep this in mind. It's easy. Just convert the dictionary back into a data frame, and boom, right? Here's your output again, right? I also wanted to bring up that storing it in a pickle file is not the only way that you can store it, right? So HDF5 is a very popular format now for storing data, especially big data, right? And Pandas gives you the ability to store your files in HDF5 format as well, right? So all you need to do here is go pd.hdfstore, and then you define your test file, right? And then when you go back to your folder, you can see that here, test file 2, right, has shown up, and it is Windows doesn't know what kind of file it is, but Python would know. And then when you want to bring it back, just take note that when it comes to HDF5 files, the way that you bring it back is actually a little bit different, right? So here, this store variable actually is kind of like a dictionary. So you haven't really stored anything in there. You just created a file. Now you need to define your key, which is what we're going to call df.
df is actually your
data frame, right, for short. And then we'll put df2, which is here, inside of it, right? So here again, we just make sure that df2 is what we want. And then we go back to the store and we ask it, we say, give me back my data frame, right? This is the key. And there you go, right? df2 shows up. So that's how you save your files to this and read it back again, without having to compute everything.
Yeah. So this is like one of the ways, or multiple ways, you can store your data frame. Wherever you processed it, end of the day, you have to store this somewhere else so that you can save your progress. So the ideal question would be, why don't you use CSV file?
Why? CSV.
Yeah.
So, normally when you have not even just CSVs, like you have JSON files, like text files, right? Like these are hard to store because they get really big, right? It's sort of hard to read in and out of memory. So like these files are just easier for the program, right, to ingest and process, right?
Yeah. So one of the things I faced when I tried to save CSV, so I was in the project, right? So basically a lot of like scientists, they just like research engineer basically try to store into CSV file because it's easier to see, you just have to like use Excel to open it out and show it to your boss. It's very easy. But the thing is, when you try to store in CSV, when you read it back, all your formats are gone. They are all read as object. Some they convert into int, but just for example, date formats, as you all know, Excel tend to change date formats forcefully. Sometimes you change it to like very nice format, you save the CSV, when you load it back, your formats are gone. Because like, I got to like you change everything again. Sometimes it's even mess up your datetime format with like American standards and the British standards. So the good things about saving into pickles, ATFS or even Felder or some other formats, which preserve your data type and the formats of the things that you're storing. So when you try to load it back, you sort of get back the same like the stage that you want it to be. It's not some other random format like CSV or text file.
Right, and when you have a lot of stuff to do, like every minute or two that you save and you don't have to go and reprocess your files is very valuable, right? So that's the to us that's the value of pickling and feathering and HDF5ing your files, right? As opposed to just storing them in typical CSV or TXT formats.
Okay, that was very informative.
Okay, so now there's one last thing that I want to show you guys. I thought it was pretty cool. So you've done SQL, right? You have queried like data sets, right? But is there like a big data set out there, right, that you can perform queries on and see the power of like SQL in the cloud, right? And the good news is that the answer is yes, right? And it's actually really easy.
Just type it there. Just click it.
Drag it up here. It's called Google BigQuery, right? So what Google BigQuery is?
Yes.
Yeah. Okay. It's basically Google has a service on Google Cloud Compute. Which I'll take a digression. I need to tell you guys about Google Cloud Compute, right? And Google Collaboratory. I'll bring up Google Collaboratory first. So that we start from the beginning.
No, not this one. You got to go new file.
Whoops.
Or you can just go create new.
You can try.
Okay, you basically just Google Collab, and you will sort of see the collaboratory. Then it's sort of like make use of your Google Drive to store the files. So you can sort of create the new Python notebooks. The good thing about this is that it uses Google Cloud platforms to train your model, even like process or run it. And you can even change it into change the runtime type into CPU, GPU, or TPU. TPU is basically fine-tuned for TensorFlow models. So if you train on GPU, it should be a lot faster than training on your local CPU. So in a way, your computer is not strong enough to train some model. You can sort of use this collaboratory to try to fine-tune your model or try to even try it out.
Yeah. So basically, this lives in your Google Drive, right? So you have a Google Sheet, you have Google Doc. You can have a Jupyter Notebook instance in your Google Drive, and Google gives you a free GPU to use with this notebook, right? So it's pretty cool. You can use this GPU for I think 12 hours before they sort of shut you down. But you can always open a new one and continue again, right?
Yes. Because that's the thing, right? You have to, after your process, you sort of store it into files, then you open your notebook, you load it back, you try to process from there.
So I think this is really important for those people who are thinking of using deep learning, right? When you're using a neural network and your computer is just not able to process that kind of data, like this is to me one of the easiest ways to step into a cloud computing instance that gives you some adequate like computing power, right, to do the things that you want to do.
Yeah, and it's easy because you just have to, like for example, you don't have to start up your environment. You can sort of straight away import pandas as PD, then it straight works. All the libraries are built in, so you don't have to manage your own libraries. It's all there.
Yeah, that's actually one of the super things, especially when it comes to installing the deep learning libraries like TensorFlow and Keras, right? Depending on your graphics card, depending on what version of Python you have, like you might end up spending a lot of time configuring your packages, configuring your run times and drivers. But here, it's all ready for
it's
you.
all ready
Right?
for
Just
you.
dive in.
All you have to do is just paste your code there, try to run it. It works.
Yeah. So that's collaboratory, right? And then Google also offers this thing called BigQuery, right? So it's on their Google Cloud platform, which is sort of the big brother of collaboratory. When you want some real 64 core CPU, and the top of the line GPUs, you go to Google Cloud platform, and this BigQuery sort of engine is part of Google Cloud platform, right? And Google actually stores public data sets, right, on this platform that you can query. So all you have to do is go to here, cloud.google.com BigQuery public data, and and you go to they even give you a web UI, right, to put in your queries. So, what happened here? So what you basically do, if we can't log in, then we'll let you explore it by yourself. But what you have to do is you just go and create a Google BigQuery project, right? You just have to sign in. Google actually gives you a $300 credit, right, to do stuff inside of this platform, and create a project. Let's call it AI for I project. And create. Come out.
It does. You can choose.
There we go. So you're in the AI for I project. Let's look for databases. Let's see if there's anything interesting. SQL, they're all. Oh no, we're in the wrong. So so as you can see, Google Cloud Platform is actually really confusing. So I would take some time to just play around and see what's available. But if we go back, right, you can see that here in the UI, they basically give you a query editor, right, to put in your SQL queries. And so you would choose a data set, and you would plug in your query right here, and then you would just press run, and then it spits out, right, whatever the thing is. So it's a great way to be able to play with data that's in the cloud, right, and a bit of a good approximation of what like the same workflow would look like when you're doing a big data project. So yes, so that is Google BigQuery. If you want to play around with this, feel free. But I think a good place to start is always SQL Zoo and SQL Fiddle, right?
But there's another thing that I want to highlight is you can go to this thing called W3 School. So it's more towards software engineering, but you can sort of learn from SQL here as well. So what they do, they can sort of give you a platform for you to run your query. So you sort of like run it, then you can see all your queries like right on the browser. So you don't have to install anything. You don't have to set up your environment. You don't even need a laptop to do it. So you can sort of see your database, whichever customers, how many records you have here. So you can sort of play around. You can even do things like join statements. Like if you want to figure out join statements, they already give you some set of example for you to try on. So if you feel like you want to try it out, you just click this, try it yourself. You can sort of try it here. All your data sets are here, like you can see. Then when you run this query, the results are here, which is very interactive. So you can sort of explore this website. website called w3school/SQL.
Right. Yeah, there are so many resources out there, right? You know, and if you want to get good at SQL, like practice, practice is the key thing, right? You know, and there's so many resources.
The more you do it, the more proficient you
become. Yeah. Okay, I think that's all I have. Is there anything
else you guys want to add?
That's all. Have fun trying to optimizing your queries and make your data more neater. Yeah.
Well, one of the things that we're trying to work towards in the next few weeks is to actually show you some local AI examples, projects, right? You know, things like, can I make a Singlish generator? Can I classify chicken rice, you know, or some other kind of Singaporean food? We're still trying to figure out if it's better to put it in like the newsletter or if it's better to do it during the AMA session. So, you know, give us your thoughts. You know, let us know if you see anything that you kind of want us to talk through. You know, and we'll try to put that into the next few weeks session as well, right? Yeah. But otherwise, have a great December.
Yes.
Have a great holiday period.
Yeah. And remember to leave any of your questions for us in the live chat, or you can just send it to us the next time the poll goes up.
Yep.
Thanks.
We'll see you again this week.
Thank you.
All right. Thank you. Bye.